All right, welcome to Introduction to Statistics. To get started, I want to get you guys thinking statistically. So we're going to go over just some basics before we get into some vocabulary that will be in your homework. First concept, the context of the data that we're going to be looking at. If I gave you two columns of data, say an X column and a Y column, and then numbers ranged between the 50s to the 60s, you don't really have any idea what we're measuring here unless I give you some context for the data. Are these jersey numbers of some soccer players or from one year to the next year? Or are they weights of, in kilograms, of course, of 5 students at the beginning and at the end of freshman year? If they're jersey numbers, there's not much we can analyze about that data except did the athlete pick a smaller number or a larger number from one year to the next. But if these are weights of students at the beginning of an end of a freshman year, we can analyze the mean of average weight gain or average weight loss. And we can look at that data more in depth. Next thing I want you to be thinking about is the source of the data that you're looking at. So if I were to tell you that in 2003, a study by Enstrom and Cabot found no statistically significant relationship between the secondhand smoke and lung cancer, you might be pretty surprised to hear that. If I told you that it was published in the very prestigious British Medical Journal, that would be even more convincing, and that it was funded and managed by the Center for Indoor Air Research. But if I told you that the Center for Indoor Air Research is a research organization that's created by 9 tobacco companies, that might change your view on the validity of the conclusions of that data, or of that statistical analysis. Another thing that we're going to worry about when we're looking at statistical studies is the sampling method. So, in 1936, the Literary Digest poll predicted Alf Landon would defeat FDR, Franklin Delano Roosevelt, by a landslide in the next election. I don't know about you, but I do not know who Alf Landon is, but I certainly have heard of Franklin Delano Roosevelt. So how did they get this so wrong? They sent out 10 million sample ballots and asked voters to return them. 2.4 million responded. That actually is a problem for now that we know a little bit more about sampling methods. That's a problem. We're going to get into that in a little bit in just a few moments. The other thing that they did is they got their selected folks who received the ballots by phone numbers, driver's registrations, and country club memberships. Now remember, 1936 is just after the Depression. Folks that have phones, drive cars, and certainly are members of country clubs are probably in a different financial bracket than those who do not. At the time, the Gallup poll was brand new, and they used a method, a random sampling method that we'll define in just a second. They only polled 50,000 people, and they correctly predicted that Franklin Delano Roosevelt would win the election. So the sampling method that we choose is going to be really crucial. Finally, how we draw conclusions is going to be really important when we're working with data. Correlation does not imply causality. So for example, a study that might look at smokers finds that smokers have higher pulse rates than non-smokers. Can we conclude that smoking causes someone to have a higher pulse rate? No, we cannot. People with higher pulse rates might be more nervous and might smoke in order to calm down. Now, it's quite likely that smoking could cause higher pulse rates, but just looking at those two factors and determining if there is a correlation does not mean that one necessarily causes the other.